Our first column packing method is called constant flow packing. We'll be packing Q-Sephiroth's fast flow to a 20 centimeter bed height in a BPG 200 column with a 50 centimeter tall tube. We're ready to start after we give the slurry a final stir to make sure it's homogeneous. Once we stop stirring, we've got to go ahead or the gel starts settling.
There, that should do it. Is the top valve in the right position?
Yes. Now we'll lower the adapter until the slurry passes just above the O-ring.
Well, I thought this was a precise operation. Why are we shaking things up?
To dislodge air bubbles under the adapter. Air is the enemy inside the column because an air bubble disrupts the flow profile in that region of the column. I'm also lowering the adapter a bit just to purge any air that might be underneath it. Now I'll tighten the O-ring and make sure the top valve is open so that the packing buffer will exit through the adapter rather than around it. Then we'll start the pump and purge the hoses from the pump to the top of the column. Next, I'll direct the flow from the pump down through the column, quickly open the bottom valve, and then set the flow rate. It's a good idea to keep an eye on the flow rate for the first few minutes and adjust if necessary.
So while the bed is forming and we have a few minutes, let's talk about constant flow packing. Okay. It's the most commonly used packing method, isn't it?
Yes, it's a simple two-step process that can be used with any media, as long as you have the right equipment, that is, a setup like this one, with a variable bed height column and a pump that can generate sufficient pressure and flow. In the first step, we send liquid, distilled water in this case, down through the column at constant velocity. The water carries the beads along until they contact the bottom net or the surface of the growing gel bed. In the second step, we'll increase the flow through the column and compress the bed to its final height. The adapter will be used to keep the bed from expanding when the flow is stopped.
How long does this first step take?
That depends on the flow rate. It usually takes about 2 column volumes for the bed to reach a constant level and for the pressure to stabilize at this flow rate. At only 20 centimeters an hour, the flow rate in the first step is relatively slow, just enough to pack the bed fairly loosely, so it won't spring back while we move the adapter into position for the critical second step.
So by getting the bulk of the adapter travel taken care of in the first step, there won't be so far to go in the second.
Yes. After our first step, although the adapter has moved significantly down the column, we've compressed the bed very little. In the second step, we'll compress the gel to our desired compression factor of 1.15, but we'll only need to lower the adapter 2 or 3 centimeters.
Sounds simple enough. What's the hitch?
No hitches, really. But there are some pitfalls if you're not careful. And positioning the adapter is critical. Okay, it took about 30 minutes for our bed height to stabilize. Now we're ready to set the adapter and finish the first step.
Can I do anything else?
Yes, I need you to close the bottom valve and stop the pump. That will shut off the flow. Meanwhile, I'll loosen the O-ring and lower the adapter.
Is there a special technique to lowering the adapter, or do you just drop it to bed level?
It takes some care. First, I'll get to within 1 or 2 centimeters of the bed. Now I'll retighten the O-ring and lower the adapter even further to within 1 or 2 millimeters of the bed. That liquid running into the waste container is being displaced back up through the adapter to remove any air. Now I'll quickly reset the valves to let liquid flow through the column once again, this time at a much higher rate. Notice that the bed has expanded only slightly above the mark on the column.
How do you know what the flow rate should be for the second step?
From the pressure flow curve for Q-Sephiroth's fast flow, the medium we're using here. We know the compression factor we want to achieve. The curve tells us the flow rate we need to achieve it and what pressure will result at that flow. The entire second step in our setup will only take a minute or two. When the bed height and internal pressure have stabilized, things happen fast, so we have to work quickly and smoothly. When I say go, please stop the pump and close the bottom outlet. I'll switch the top valve and start lowering the adapter. If you can watch and tell me when the adapter reaches the bed height we marked, we can finish this pack. Ready?
Let's do it.
3, 2, 1, go.
Wow, that was fast. And right at 20 centimeters. Okay, I understand the need for delicacy, but why is speed so important?
The bed is compressed like a spring. When the flow stops, there's no force to keep the bed compressed. So it begins to expand. If the adapter isn't put in place quickly, too much expansion will occur and we won't achieve acceptable compression.
You and your staff have a lot of skill and experience at this. What about klutzes like the rest of us? We're bound to mess things up now and then. What do? Throw everything out and start over?
If you were not able to get the adapter down to the line in the second set, you can add a third step by simply repeating the second. If you can't get it in 3 steps, start over.
What test numbers would be obtained from a column packed by this method?
Using a 1% sample volume at a testing flow rate of 20 to 30 centimeters per hour, we should expect at least 4,000 plates per meter with an asymmetry between 0.8 and 1.5. You might want to review the recommended testing procedures and variables in the evaluation section of this CD before you begin testing.
Good idea. Thank you, Dr. Sullivan.